from the previous section. So just a quick, not what we have learned till yesterday. So it's Hadoop, basic architecture of Hadoop. Actually, how big data should work. Okay, the basic architecture, how the thing is fault tolerant, how if there is any failure between any jobs and how it should restart with another nodes. That is the way, and Hadoop, the architecture between Hadoops and the other modules is combined such a way that if any node fails in any time, if the job fails at any time, it can be restarted with another node. Okay, so this is the, good thing we can see in the Hadoop part. And so, if there is any stuck point or any doubt or any confusion, you can kindly tell me. Okay, I hope no. So let's get started with the rest of the part for Hadoop. Not rest of the part, actually Hadoop is also a vast thing. But for 2 or 3 days, it's basically a very few thing we are learning over here. Uh, but as much knowledge we can push, so that the basic thing will be clear to you. Later, if you have some more, interest on Hadoop and all, then you can study other courses, or maybe I have some opportunity in future as well to take Hadoop only as a learning kit over here. Then I'll be taking this thing with more detailed manner. Okay, fine. So let me open the. Let me. Okay, fine. So yesterday, what we have learned, it's totally Hadoop core system. Over there, we have learned 3 modules. That is HDFS. This is the base module of Hadoop. That means it's just like understanding how the distributed file system works in Hadoop. Okay. On top of HDFS, there are Yarn. Yarn is the resource manager. It's allocate the resource when it's required. When it's not required, it's take it from the allocated resource. It can also take it or pull it. Okay. So on top of that thing, we have the main map reduce thing, which is working as a action of Hadoop. How the data can be mapped and then reduced. This is the way the data, the compute data can work as a distributed manner. The computing thing should be distributed in manner. Not only a single machine have to do the compute power, or they have to utilize their compute power. A vast of compute machines, they are, going ahead with their computing power. Okay. Now I'll be learning. What we'll be learning, we already showed to you that this kind of architecture. So over here, we'll be learning today Spark. Spark is a top technology nowadays. So Spark is also, based on Hadoop, it is working. But as per the architecture diagram, you can see Spark is only taking HDFS, the file system from Hadoop. The resource allocator and a map reduce is already also been provided by Spark by itself. So we are not taking MapReduce and Yarn part from Hadoop. Sorry. Okay. So Spark is not using MapReduce and Yarn from Hadoop. It's only using HDFS file system, and the latter part, MapReduce and Yarn, it should be Spark's own. Spark has the capability, and the particular one who have designed Spark. Spark is owned by Apache. It's a company name. Okay. So it's having the capability of doing the MapReduce and Yarn inside itself. Okay. So I'm moving ahead inside the Spark. What is there or what is not? So basically it's a first and general engine for large scale processing. So this is the stuffs actually what we have learned for Hadoop. Similar kind of architecture is also there for Spark itself. So let's go ahead with some basic example. If we are doing some PySpark coding, just whatever we have learned at the Python side, the same thing we need to write over there on top of Spark. Let's check Spark modules. Okay, so Spark inside Spark, what are the different modules? There's Spark core layers are there. Core layer means that particular resource yarn kind of stuff is also there, as well as the map reduce action items. Those are also present there. Those are called Spark core. So inside Spark core also we have some more thing. So we need to learn Spark context, how I can enter a program, or how I can drive a program. I mean, how I'll be just putting the code over there. Before that, I need to create a Spark context, which will help me to get entry to Spark code or various resource allocator. Okay, I'll be just coming to this topic quickly. Spark SQL. This is one of the important stuffs as well. So SQL engine is also there on top of Spark. That is called Spark SQL. Apart from that, we have the below three as well. Spark. For Spark, there is streaming, Spark MLib, and Spark GraphX. So the last one is for graph theory and all. For streaming purpose, we also use Spark streaming. Okay. But today we'll be mainly focusing on Spark Code and Spark SQL for our data related stuffs as of now. Big data handling and all will be concentrating on top two modules. Okay. Okay. And I mean, whatever we are writing code on top of Spark, there are four languages are available over there. Python, Java, Scala, and R. I mean, Spark internal language. I mean, how Spark is designed, the internal language is Scala over there, Scala scripting. So if we, basically develop the code by Scala, then it should be good. There should not be any interface mismatches. But we have opportunity to work by Python as well. Python and Scala is almost same. There is a bit language difference. That's all. Okay, Python, Java, Scala, and R, any one we can choose and start our coding. Okay, if we use Python over there, it's called PySpark. Okay, so we can choose. As of now, I think I have chosen Python for my next slides. Some of the slides are also consists of Scala as well. Just like the basic difference, if you could remember, when we are typing Python code, when we are assigning some value to a particular variable, suppose uh, in Python we are just typing a variable called v equals some value, suppose 7, v equals 7. But over Scala, there is the syntax mismatch is just like this. If it's a variable, then we need to declare var, var. Var is a keyword, var v equals 7. So this kind of very minimal syntax mismatches is there. So we can go either way. I'll be just showing this thing. I have in my next slides, we have Python codes as well. Some of the code snippets are from Python and some of the code snippets are from Scala. So you can check the difference quickly over there. Okay. So for the Spark code, how the thing, should be work over here. So when we'll be, writing any kind of developed code over there. So first of all, we need to start a Spark context. So this is the entry point of a program. So when we start the Spark context, it will discuss with cluster manager. Cluster manager is just like the same thing as yarn from Hadoop. Okay. As I told that we are not taking the activity of yarn and MapReduce from Hadoop. Rather, Spark has its own cluster manager as well as MapReduce component. So we just have to create a new Spark context. Spark context we will discuss with cluster manager and assign the worker node. Okay, worker node means the data node, the task node. Okay, so there are executor. Executor means separate machines. We can tell EC2 servers if we are taking into account for AWS. Okay, each of the worker node you can see more than one task nodes are available as well. So those are the executor box. Inside executor box, those are task nodes. Okay, executor nodes should be having some memory allocated with it. So when running the job or when running a batch of jobs, we can assign this value. What should be executor memory's value? How many worker nodes I can attach to it? How many task nodes we can attach to it? We can just update it at the runtime while running a job. Then everything should be distributed in manner by cluster manager, and compute processes also been distributed over there. The similar way what we have learned in Hadoop. Okay, but today we'll be mainly focusing the coding part. I should be gradually entering inside that thing. Okay, so first of all, as for the data engineering perspective, this is the basic data structure for Spark, that is called RDD, Resilient Distributed Databases, data set. So how it looks like or how it should work, and this is the fundamental data structure of Spark. So when Spark is now we are in Spark, the current launch version is 3, okay, 3.x. So when Spark launched for the first time, this is the basic one and the only one data structure available. Just like in Python, we are learning list, dictionaries, and all. For our, for Spark over here, the basic data structure was RDD, that is called Resilient Distributed Data Set. Nowadays, in Python 3.x, there is also two different data structure. One is called data frame. So data frame and data set, those are almost very similar kind of stuffs, but data frame doesn't have any schema with it. Data set is having a schema with it. What is this and what are the difference between all of them, RDD, data frame and data set? I'll be coming. But just to let you know a quick introduction for data frame. Data frame, what we have learned for pandas. In Python, we have created data frame. Means from linear data, we have tried to, just like from dictionary, when we are using, by using pandas, we can convert this dictionary from dictionary format to structural data. That is called data frame. It's similar kind of stuffs. We can create the data frame by the same thing. So data frame and data set is almost similar. While creating data frame, we are not assigning the column. The schema name is not mentioned inside the data frame, but over data set, a default schema is been declared. Data frame and data set I will be coming later. Just, I'll be covering RDD first. What is RDD and all, how to code within RDD. So let's cover that thing. So first of all, yeah, I told you that we need to create a Spark context while writing a program. So it's a mandatory thing. It's just like a entry point of this program. So created by driver program means we have to write it by our own. It should be at the first line when I'll be declaring any RDD. Responsible for making RDD. So this Spark context will create a RDD for us. Not only one, multiple RDDs can be created as well. Okay. Okay. How to create RDD? I do not have a quick, tool to go ahead with hands-on because I can launch a EMR clusters and all to show you these things, but as of now, no infrastructure is there. But Lohit has helped me with some portal and all. I'm trying to registering it. Last session also I haven't complete that steps in the hands-on perspective. That's why I have put those code snippets so that you have some basic ideas on top of Hadoop and Spark as well. But I am working with some portal. I was just working on that thing. So maybe by the next session I can able to do that thing. This is the Unravel thing. I'm checking on top of Databricks or Amazon EMR. There is some free, actually, what I can say, free account I can create and use the basic stuffs over there. So basic coding skill, like we can able to learn it. I'll be checking it by this weekend if I get some free access and all. I'll be showing you this thing with the coding thing or the code snippets what we are showing over there in our PPT. The same thing we'll try to, execute the thing over here and we can check how faster is this. If it is not possible, we can then maybe next session early I'll be touching quickly that Hadoop part again. Okay, with a quick hands-on, maybe for one day. But the code snippets are quite helpful as of now. You will be having idea. Just like how to create the data frame in the pandas, we are just declaring df, that is data frame. Data frame is a variable equal pandas, or maybe on top of list how we are creating this pd dot create. From create CSV we can create another one. From dictionary we can create data frame was the method pd dot create data frame, and now I was pointing to list or I was pointing to a dictionary. So the same kind of stuffs we have done over here. We can correlate the thing with Python code. Even it's a Python language itself. RDD is a variable. Just we are assigning how to create the variable. It's spark dot spark context. The spark context that I told is the entry point of this. So while creating any RDD, so we need to use this spark context over here. Spark dot spark context dot parallelize. Then I'm just passing a list. So the output should be a RDD. It's a basic data structure inside inside that particular course. Program over there. Okay. And on top of RDD, why we are creating RDD actually? So as I told in Spark, this is the basic architecture of uh, our basic data frame of the data, our basic data structure of the data. So if we just go ahead with any data manipulation, which should be working as a distributed nature or distributed computing power, it should be using from Spark architecture. That's why RDD, we are creating RDD. Okay. We can create multiple RDD and then we can manipulate it. So all this kind of operation. Sorry, anybody is telling anything? Okay. I hope there is some noise over there at the background. So just like whenever we were learning the Python data frame at the Python classes, so there we are creating multiple data frames on top of pandas, and then we are manipulating the data. Maybe we are joining this. Maybe we are just doing concatenation. Maybe we can do lots of aggregations on top of each of the data frame. So the same kind of stuffs we can do on top of RDD. So that's why this kind of list or dictionary can be converted into RDD. Okay, when the RDD is ready, then we can go ahead with this kind of manipulation, data manipulation or data analysis, rather we can say. Okay, that's why we are converting into RDD. So just like we can also do the thing from this way, text file or any file that is being stored in HDFS, the distributed file system. Maybe any file that is stored in S3 bucket. S3 bucket means suppose we are working in EMR clusters. It's having some S3 bucket as well in the same account of AWS. So it's collaborating. EMR is taking data from S3 data lake. So we can put the file structure over here. The similar way what we have followed in pandas when we are creating data frame on top of some CSV file. CSV file if you can remember, we just put some local drivers or local driver CSV. We are just pointing it and just putting pandas dot create from CSV, and then we are putting the entire CSV path. Then our data frame can able to create the data frame on top of that CSV. The similar kind of stuff we can do over here as well. There'll be no issue. So this is the way to create the RDD, resilient distributed data set. Now for different kind of function we can go ahead with RDD. Those will be mentioned in later section. So a code snippet is also there. So just see the difference This is the uh, PySpark code. I'm not using var over here. It's directly RDD. Okay. So this is the difference. We are using val. Val is the constant term. It's a scalar scripting. It's almost similar. No difference. We are using the same methods. Spark context parallelize data sequence. So we're just declaring over here a data sequence at the beginning. Okay. And val is the, constant term, not variable. So there are two kind of stuffs over there in Scala scripting. One is var, another one is val. Var should be variable. We can vary this kind of variable while we are running the program. But val cannot be varied. I cannot assign another value on top of data sequence because I have already declared it as val. So those are the basic coding changes or coding modification or coding difference between Scala and Python. I'll not going to deeper way, but as you know already Python, so it's similar. I mean, just a basic or few syntax changes over there. So over there, I'm just declaring a sequence. Just like Python, we do not have just like the same list dictionary naming convention over here. Rather, I can say it's sequence. It's also just like a key value pair. It's similar kind of dictionary what we have covered in Python. So over here, it's called sequence. Okay, so here key value pair is mentioned over here. It's like Java 20,000, Python 1 lakh, Scala 3,000. And now I'm just converting this thing, the data sequence in RDD. Okay, so val RDD, val means another value or constant term RDD equal spark context dot parallelize, calling this data sequence. So on top of this data sequence, it's creating the RDD. Okay, so that's all for creating an RDD. Nothing, no difficulties on that. So the text file creation as well, we can create in this manner. The same thing is there what we have checked for Python. Okay, now when the RDD is there, there can be two operation we can do, transformation and action. Okay, transformation is the thing, from yesterday's slides, if you could remember, map and reduce. Two things are there for the distributed architecture or distributed computing system. So transformation will be working as a mapping thing and action should be reducing the thing. Okay, so what are the different transformation? Okay, there are maps, flat maps, filter, distinct. Those operations are called transforming an RDD. So each row can be mapped with each particular element. Okay, so RDD should be just like a tabular structure. So each of the row we can map with any particular element or any particular things. So that is been mapped. Each of the row or each of the set of the row. Maybe I have told you we have a large data set. So based on a column or based on a columns group by or based on a particular Windows function, we can segregate or split the rows based on, suppose we have entire school's data for students data, how, what are the numbers they have received and all till 5 to 10. So we have partitioned the entire rows by classes. Okay, so we can pass the thing, we can map the thing for each of the classes data. I'm passing or mapping the thing for a particular operation. So while doing the map operation, I'm segregating the classes data, means I'm splitting the data and going ahead. It's going ahead with each of the executor for the execution. So that's why map is important. It's distributing the data. Okay, not only one single machine, not only one single executor will work on that thing. It's been mapped with different executor. Okay, that's why, why we are not using Python? The same manipulation I can do this thing by Python only. Why I'm choosing PySpark? Because in Spark, it's distributed in nature and this kind of operation map, flat map, those transforming RDD will help to distribute the data among different clusters. or executors. Okay. So this is the thing. I'm using a lambda function over here. So RDD, that same RDD I'm doing, map is the particular method, and just like I'm doing x, where x signifies that x equal x cross x. That means I'm just doing a square of a number, and it should be occurring for each of the element, but it should be distributed in nature. Okay. So how much powerful it is. I'm not doing the operation only. I mean, I'm not doing the transformation, as well as the transformation will be distributed in nature. Okay, along the entire executors. Okay, so just like map, we have the reduced parts as well. Those are called RDD actions. We are collecting the data, collect, count by values. Basically, those are all aggregation functions. Okay, the same thing we have told yesterday's session. So we have map and reduce. Map is being done by all the executors, and reduce will be reducing the number of executors over here one by one, and we can receive the final result. Final result should be given back to Spark driver again, and driver can show the output to the user. Okay, so we'll be releasing the executors as well when we'll be performing the particular reducing part. So those are the things: collect, count, count by value, take, reduce. Those are the action item on top of RDD. So when we have mapping this, when we can do this kind of lambda function over there, lambda, and we are getting each of the particular elements squaring part, then we can collect the result for each and print ln. We can print the output. Okay. While printing the thing, after, the printing is over, we are coming out from the Spark context, and we can display the result on top of the screen. So we can release the executor as well. So whatever executor I can get assigned by the Spark context and the particular resource manager, the same executors can be released as well after collecting the result and pushing the value to Spark driver. Okay, I'll be just showing you some more architectural diagram from a portal. If the things are quite tough, what I'm learning, what we are telling over here, we can quickly show you the thing. So that thing should be helpful. Okay, let me show you something. We have some good portal as well for learning purpose. Spark by example. Okay, just one more thing. So RDD we have almost, I'll be just covering the thing once more time. Then you can also check at your side too. If there is any difficulties for learning or anything for the basic side, I can definitely help you. The same RDD, I'll be just showing you this thing in your portal, as well as the next thing, the next data structure is called data frame and data set. I'll be coming to this topic quickly. But before that, I'm just going to this portal. So how Hadoop should work over here? One thing, you can learn this thing over here as well. Spark by example, it's very basic thing, and from the beginning, you can learn it over here as well. Okay. Yeah, I just keep this kind of stuffs over here. And for the installation part that I was telling to you, while installing the thing, as we are lending Hadoop's architecture, we are taking Hadoop distributed file system from Hadoop. That's why if we just work on top of Spark, you want to install Spark, first of all, you need to install Hadoop. Okay. And there is some version kind of stuff. If you are installing a Spark, then its corresponding version of Hadoop you need to install. Because just like here is a usefulness of this. So we have, I'll be showing this thing to you soon. If you just click on the Spark download over here, there is a link. So it can help me if I just install any kind of, yeah. Now current version of Spark is 3.3.2. So if you just want to install anything over here, you can check what are the default or what are the useful of particular Hadoop. Maybe I am installing a different version of Hadoop which is not compatible of that particular Spark version. So check it from here, from the drop down list, so that it's matching. Just like 3.3.2, then Hadoop cannot be 3.2. Hadoop should be 3.3 or later. Okay. So just check it from here. If you want to try, I mean, in future, if you want to install Spark, then you need to install Hadoop. Check which version is suitable. You have one version of Spark, then which version of Hadoop you need to install. Just check it. Download it from. I mean, here is the download link as well. You can also download it from web as well, and install it at your system. Okay, both Spark and Hadoop. But it's not easy actually. Spark should be working as a distributed manner. If you have in your system multiple core system, then it should be fine. Otherwise, there will be no difference. I mean, whatever we are getting for Python speed for manipulation, the same thing should be Spark as well. Because we do not have multiple cores over here in our system. Cores means CPU core. Okay, I'm telling about. So if we have distributed nature, if you have multiple machines connected with some LANs and just like this, so if we have this kind of architecture available, then we can use this thing, we can distribute the thing among different clusters and work it. But the proper infrastructure is required. So that's why the best way is to learn Spark and all. If we have any kind of, yeah, that thing I was telling to you earlier. Lohit, help me with the particular portal. Yeah. So over there we can get Databricks or EMR clusters. EMR is from AWS that I told you in the last day. So we have the EMR clusters ready. We can uh, run this program and we can show you that how the executors are working independently to do the computing things at their side. Okay. Okay. Now coming back to this data frame and data set. So RDD, the basic stuffs is there. We have already covered. So there are not much things we just have to learn. How to create an RDD. Okay. So it can be created from an external data sources as well. Maybe external flat files, or maybe the data is being stored in some S3 buckets, or maybe it's in HDFS file system. So we can use those kind of code snippets I showed to you earlier. So that's the way we can create the RDD. After creation of RDD, we have to do some mapping operation, that should be a transformation. And at the final, we have to push the result to the driver, and that should be reduced in nature. We can there are multiple functions available for aggregations and all, so you can use that thing. But for the coding practice, you need to go ahead some more details. Okay, let me open Spark by examples one more time. Here, if we just go ahead with RDD's topic, at the below, yes. So the same thing, read from CSV, read from text, create RDDs. What are the different actions? Okay, partitioning the thing, cache, you can go ahead with these stuffs as well. But those are some detailing manner over here. If you face any difficulties, you can go through this thing by your own. But if you are facing anything, we can connect in another day to clear your doubts. But please tell me that you are, you are facing difficulties while learning the stuffs from here and all. Then we can just think about any other stuffs. But try to learn it from here by this portal. It's very much helpful. And the same thing, I mean, the basic part is this, just like create the RDD, transform it, learn how to map on top of that one, how to flat map on top of that one, how it should work, and use some action items. Action means that particular reducing part. Okay, those are the main three things for the RDD to have some basic coding practices. Okay, now I'm going to the data frame itself. Data frame and data set. It's almost same, but only difference when we are declaring data frame. Data set is the most recent API. in the most latest version of Spark, dataset is been introduced. Okay, and data frame and dataset, it's almost same, just like I told you. It's similar kind of Python data frame as well, I can tell. We already have the experience of Python data frame. I mean, on top of pandas, we have created this thing. So the same thing, we have data frame and dataset. Dataset will come with the inbuilt schema pattern. I mean, the columnar structure should be defined over there. I mean, the header part should also be coming, but data frame, it's not. The schema name will not be defined at the beginning. Okay. So it's just like extends, I mean, higher API of the RDD. We can create data frame and dataset on top of an RDD. Okay. It should contains row objects and column objects as well. The similar kind of stuff as table particularly. There should be table and columnar structure should be already present. I'll be inserting record as a row objects. Okay. On top of data frame, I can run SQL queries. That is called Spark SQL. Spark has that SQL engine inside itself. Okay. Has a schema. But the schema is not present for data frame. It's only for data set. Okay. This is the main difference. Schema means we learned about SQL. Then we are declaring the columnar structure for a SQL. So similar kind of thing is there for data set. Okay. So here is the example how to create a data frame. So this is the particular thing has been designed on top of Scala. So I'm declaring this value. It's a sequence. Each of the things when we'll be creating the particular data frame, each of the things should be working as a row item or row objects. You can see. Then we are declaring the columns as well over here with another sequence. And this is the way we are creating a data frame. Spark.create data frame. On top of this sequence, I'm creating data and I'm creating the schema as well over here. That means it should be working as a header part of that particular data frame. Okay, so just like data is this, column is this, and I'm merging entire stuffs over here. Okay, and creating a data frame. And if we just put df.show, just like print df we are doing at the Python side, just over here, the logic should be df.show. Show is the method. Okay, so we can able to find this kind of tabular structure presented over here. First name, middle name, whatever we have data entered over here, the same thing should be presented in a data frame. So the similar kind of stuff I just want to mention why we are creating data frame. It's the actually we are learning data engineering. Okay, so I mean we are learning data engineering. That means the data we have to convert it either in RDD or data frame if we are working in the big data, because we have to manipulate the data. We have to, I mean, we have the work for analytics part. We have to analyze the data. That's why we have to convert the data into a particular data structure of that environment. So here the data frame or RDD, we need to choose anything. RDD is the old API. It's the preliminary API. Some of the operation is suitable for RDD, then we can work in RDD. Otherwise, nowadays, as data frame and data sets, those are the recent data structure. We have to go ahead with data frame or data set. Okay, based on the program's, I mean, criticality or suitability, we need to choose what kind of data structure we need to declare. So data frame is the most, I mean, not most, data set is the most, data frame is below that. So any of the API we can use over here. This is the another thing I told you, SQL engine we can work. So how to do that? The same data frame on top of data frame, I'm using this kind of method and storing this thing as a tabular format. So person data, just like I'm creating creator replace temp view. This is the particular method. On top of the same data frame, I'm just rewriting that thing, person data. So it's stored inside the data now, inside the table. Now I can use Spark SQL on top of this person data and use the SQL engine. Okay, so this way Spark SQL should work. On top of data frame, I can just store it as a tabular data, exact table. Okay, and we can do any kind of query on top of this data frame. Just we need to write the syntax earlier on top of this data frame. Okay, Spark SQL should work in this way. I told you what is Spark SQL, but this query engine should be it's optimized in nature because it should be distributed. When I'll be doing select star from person data, not only one executor will return the value, that thing should be mapped based on the partition of this person's data. Okay, just like I told you for the student classes, there are various classes. Just like the particular thing should be partitioned on top of class. For fifth class, one executor will be handling. For sixth class, one another executor will be handling. So when just pushing the command select star from person data in the backend, it should be splitted among executor. The executor will be doing the select star from for us, and each of them will showing their part, and finally I can get the output from one driver. Okay, so similar kind of stuffs we can create the data frame from file system as well, from JSON structure as well. So this is the way we can do this thing. Even from a external table, suppose we have Hive as well. Hive is another add-on on top of Hadoop. We have the query engine on top of Hive. So just like the code should be Hive context.sql. From Hive table, I can fetch the table and create a data frame in this manner. Okay, so those are all the example for creating data frames. And those are all operations we are having on top of data frame. We have filtering part, similar kind of data. I mean, what we have done for pandas data frame. And if you just quickly remember, we have done the filtering, slicing, those kind of parts are there. The same kind of stuff, this kind of operation is also there. Just like group by, you can see. Okay, so all this kind, the only difference between Python pandas, pandas data frame and this data frame is it's distributed in nature. The thing should be much more faster. Okay, all the operation should distribute the data among different cluster, and the final result it's reducing the thing, and they are returning the thing to drivers. But in the Python pandas, it's only one single executor, single machine. I'm working on that, and it's the thing should be much more time consuming. That is the difference. But we have already learned the data frames there. The similar kind of concept is there from the functional point of view, but the particular coding syntax is different a bit. If you can remember group by over there, we are doing group by on top of particular column, and then we are mean operation over there. It's similar kind of syntax, but a bit different. Okay, this is distributed in nature. That is the main difference. That's why if we are processing billions of rows, if we just go ahead with data frames operations from Python, we can see what are what what are the things going ahead with faster way or smoother. Okay, so those are the stuffs. I think we have covered almost everything. Yeah, Spark submit. How to submit a code here. This is one of the most important steps. If you are running a bunch of codes over there, and we are calling the batches to call all the batch or call all the scripts at a single run, then this kind of stuff, just like mainly focus on this kind of stuff. Executor code, how many code I will be assigning to run the thing. Executor memory, I can give the value, it should be GB format. Driver memory, what should be driver memory? So that can be working as a main parameter over here as a big data. I can push how many numbers. I mean, suppose I am working in a EMR clusters. Maybe there are 100 executors are available. But while running a particular jobs or by batch of jobs, what we have kept in the jar format and all. So while just triggering this kind of Spark submit job, this is the command while submitting a job, Spark submit. Then we just need to put the particular stuffs where the jobs are stored and this kind of parameters, driver memory, executor memory, executor code, this kind of three important aspects. So suppose I have 100 executor, I can just pass 16 executor over here. Based on the partition, we can see, suppose we have 10th classes in the particular results over there. So I can pass 10 executor. And if I partition the entire data set by classes, then each of the executor will be taking each of classes data and they will execute the thing. That should be much more faster than a only single Python commands result or any other programming language you are just doing as with a single executor. It should be 100, not 100 time actually. As we are using 10 executor over there, it should be 10 times faster to get the result output. Okay. So that way you can submit the thing for a batch of job, but only for a single job, or is there anything, any just like this? There is also debugging part. We can debug the thing from our UI side as well. Spark has its own UI. Apart from that, I mean, whatever we have learned, just like Apache Embody in yesterday's session, Apache Embody is a, also, Hadoop's add-on services to check the jobs running status, how the executor are taking the data and they're releasing their nodes as well. The similar kind of stuffs we can see from Spark UI as well. The running jobs, this kind of stuff should be there as a code snippets. So those are the jobs, their description, which particular time they have submitted, how much time they're taking, and their task was completed and how they're submitting their jobs and all. So lots of rows should be available over here based on number of executors. Okay. And how the executors are finishing their works and they're handing this thing to driver side for the reducer part. Those can be seen from this portal side. Okay. That's why Spark UI should work. Okay, the time and number of executor, their IPs as well. IP should, you can also check each of the executors IP. Okay, so how much time they're taking and all. So this kind of stuff we can check. Uh, yeah, that's as of now we have covered the basic. It's very basic. But if there is any doubt, if you are trying to learn some more deeper way, if you are finding any doubts or if you want to get it clarify something more, you can just quickly get in touch with Spark by Examples portal. If there is any stuck point, please tell me. We can connect with the next class for a quick doubt clearing. Okay. Okay, then I think everyone has dropped. Maybe they're not. It's not helpful the same session to them, or maybe it's a bit tough for Hadoop over here as we have started with SQL and Python first, and later we have added Hadoop. But we just push some basic knowledge over here. Uh, if there is any stuck point or anything, please reach out to me in the later sessions. Okay. Thanks everyone. As of now, we have covered Hadoop. Next stage, we will be learning Git. This is the last topic. If there is no such doubt from Hadoop, we'll be covering Git and the course will be ended. Maybe Monday or next Tuesday. We have one Python exercise given to you. So we can solve the same thing in the class as well. If there is any doubt, also ask me. Okay. Okay. That's all for today's session. Let's connect on the next day. Thank you. Bye bye.